Hello, in this video we're going to work through this problem here. So a rhombus of side 4 centimeters has one of its angles 48 degrees. Calculate the length of the diagonals. So the first step of this problem is identifying what is a rhombus. And a rhombus is a parallelogram whose sides are equal. So I can take a second here and draw a quick little sketch. And I can't stress this enough. If you don't know what to do, draw a diagram. Diagrams are great for figuring out what steps to take to solve a problem. So we know that one of the angles is 48 degrees, which is there. And since this is a parallelogram, then we know that 48 degrees is there. And if I want to calculate the length of a diagonal, let's actually put this in here to here. So now I need to kind of figure out the next step. So we know the length is 4 centimeters, and they're all equal. So to help with discussion of this problem, I'm going to name this parallelogram, or this rhombus, ABCD. And what jumps out at me right away in this is the fact that I have an isosceles triangle. You can see the isosceles triangle here, BDC. The reason why it jumps out at me is because currently we're working with right-angled trigonometry, and the nice thing about an isosceles triangle is if I bisect the angle at the peak, I also bisect the base and I bisect the angle there. So what I have here is, let's draw a little diagram off to the side here. I end up with this situation right here. So this is C on my diagram, this is B, and then let's call that E. So this is a point here, E. So if angle BCD is 48 degrees, I know that BCE is going to be 24 degrees. I know BC is 4 centimeters, so I can say 4 centimeters here. So therefore, what I can do now is I'm interested in length BE, let's call that X. I can say that sine of 24 degrees, don't forget that degree symbol is the opposite, which is X over 4 centimeters. So X is equal to 4 sine 24 degrees. And I'm going to leave it like this for the moment, just because that's exact. If I type this in my calculator, I'm going to get some decimals, which are fine, but until I know what I want to do with this, I'm going to leave it in the form 4 times sine of 24. So since I'm interested in the length of the diagonals, I'm interested in length B to D. So therefore, BD is equal to 2 times X, which is 2 times 4 times sine of 24 degrees, which is equal to 8 sine 24 degrees. And now if I wanted to, I could get my calculator out. 8 times sine of 24. Had a calculator error there. Oh, I think my calculator, you can't see this, but I think my calculator might be in radian mode. So let me check. That makes more sense. So I get a length of 3.2. Which makes sense to me because if I look at this isosceles triangle BCD, I could calculate the angle in here and in here, and I know that angle DBC will be 66 degrees, so that means DC is going to be longer than BD, right? We're using that idea that smallest angle is across from the smallest side, largest angle is across from the largest side, and the middle angle is across from the middle side. So now, note this question says find the diagonals, plural. So let's take a second, let's calculate the other diagonals. So the other diagonal cuts down through here. So if we call this length in this diagram y, can you put y is CE. So I can say that cos of 24 degrees is equal to y over 4. So y is equal to 4 cos 24 degrees. Don't forget that degree symbol. And again, I'm going to leave it in this form because it's more exact in working with decimals. So therefore, what I can say is CA, length CA, is 2y, which is equal to 2 times 4 times sine of 24 degrees, which is equal to 8 sine degrees. Oh, I've made a copy error here. Not sine, 2 times 4, cos of 24 degrees. Cos of 24 degrees. So we type that in my calculator, 8 times cos 24, and I get a length of about approximately 7.3 units. Okay. So again, with this problem, it's really important you know what a rhombus is, and I would add that shape to your vocabulary that you just know. And one thing I want to stress, when we're doing problems like these, draw a picture. Draw a nice big picture, and you can then easily label and add all the different information you find out about that situation. Two little things that popped up in the algebra here to remember. The first thing is that if you get to a point where you have 4 sine 24, just leave it like that until you need to substitute later. This is good practices to develop. This is a good practice to develop now in your techniques, because it means you're getting more accurate answers because you don't have to worry about rounding decimals. Also, remember, we're working with angles, so always check to make sure your calculator is in degree mode. When I was first doing this calculation here, I was getting the wrong answer. And that was because my calculator was in radians, which is a different unit of measurement for angles. I hope that helped.